the thumbnail is right. The manufacturer is telling you a different oil than they use themselves. We're gonna tell you about it in just a second.
You should always use what's recommended in your owner's manual.
The manufacturers backtrack what oil they recommend all the time. Just like in the teaser, right? Lamborghini, they came out with the Lamborghini Aventador, and the official oil of Lamborghini is Castrol. So if you go to Castrol's website, you can see in their product finder that for the Aventador, it should take a Castrol Edge 5W30. But if you go to Lamborghini and you pay for an oil change, looking at the receipt, you can see they use a 10W60. Or how about Audi, where with the Audi R8, they recommended switching from 530 to a 10W60. Or BMW, in the early 2010s, they decided you could go 15,000 miles between oil changes. If you own a 2012 or 2013 6 Series, guess what? There's an active recall for you to go to the dealer so they can change your oil change interval from 15,000 miles to 10,000 miles. They get it wrong. Just taking what the manufacturer gives you is not really the best way to determine the best oil. Manufacturers know that very few people know about oil, okay? Especially you. Let me prove it to you. Which oil do you think flows faster or is thinner? An engine 30 or a gearbox 75? The 75 is actually a lighter oil. We'll get into that later on. The point is, you don't know about oil, no one at your local dealership knows about oil, and Engineering Explained knows nothing about oil. And he should have done his research. He should have been the engineer and brought you data, but if you look in the bottom left-hand corner of his video, you can see it's sponsored by Mobil 1, one of the largest manufacturer-recommended oil suppliers in the world. So, of course he's not doing his research. He's after the bag, the dealers are after the bag, Mobil's after the bag, everybody's trying to get paid, so they're not looking out for your best interests. So I'm not an oil specialist, but I am going to back up everything that I give you in this video with a study or a scientific paper to back it up. I've spent the last year and a half researching and testing and hunting down experts, and I've done hundreds of oil samples and oil tests. And I don't mean like pouring oil to see which one runs faster or spinning a bearing and doing things that don't exist anywhere in your engine. I'm talking about actual chemical analysis. You can test the oil that comes out of your engine to see which one's better, and I highly advise you do it. It saved my clients over $100,000 in the last year. And I know I'm gonna lose a lot of you with technical information here, so before I lose you, let me just go ahead and show you some oil analysis that will prove to you which oil functions better. Here we have a Porsche GT3 that started with Mobil 1, and then we switched it to Redline, and as you can see, across the board, the wear metals in the oil dropped by half. So what is oil? Well, first of all, you may know it comes in two basic flavors, right? Like a conventional non-synthetic oil. A good example of that would be this Castrol Edge 5W30. Well, you thought that because it says full synthetic, that it's actually full synthetic. Now, conventional oil is made from good old dinosaur crude oil pumped from the ground. And if we look at the material safety data sheet on Castrol's own website for the Edge 5W30, you can see that a majority of it is petroleum distillate with heavy paraffinic. That is then treated and a little bit of synthetic additives are put in, and they call it a synthetic because it behaves like a full synthetic. Maybe it's making a little bit more sense now why Mobil 1's owned by Exxon, Castrol is owned by British Petroleum, and Pennzoil is owned by Shell. It's because they're taking a byproduct of their gasoline refinement and repackaging it and selling it to you. But it's what the manufacturer recommends, right? Or is it? You see, Lamborghini has a race league called the Super Trofeo class, which is where pro amateurs can take a race Huracan with a stock engine and race against each other. And there are rules for this league. So let's see what oils the league recommends. It's a Castrol 10W60 or a Pertamina Fastron 10W60. So let's go check out their website. And if we go there, we see Wow, they're touting that they were made specifically with the Lamborghini Squadra Corsa team for their race cars. And it's a fully PAO base stock. That is a real synthetic. A PAO or ester blend is a lab-made synthetic hydrocarbon oil. Petroleum oils are made from a petroleum base stock, whereas a real synthetic is made from either PAOs or esters. And actually the best oils like Redline or Motul are used from a blend of PAO esters, combining the best of both. PAO, for instance, is non-polar like petroleum, but ester is highly polar, so it really holds on to its additives. PAOs cause seals to shrink, and esters cause seals to expand. So a perfect blend of PAO ester is the ideal real synthetic oil. They also have the Lamborghini logo directly on the bottle. So which oil do you think Lamborghini actually thinks is better? Why is the manufacturer using it themselves but not recommending it for you? They say it's overkill for you. You don't need that good of an oil. I mean, you're going to buy a new car in a few years anyway, so why spend so much more money on an oil that you don't need the protections of? Wait a second, you don't need protection from oil? You should use something subpar just because it's a little bit more expensive? No, it gets a little deeper than that. Petroleum companies virtually give it to car manufacturers, which save car manufacturers hundreds of millions of dollars a year, being that they have an oil that they can be involved in the development of and gets put into their cars. And then the manufacturer puts a little sticker on your car saying, make sure you use Mobil 1, make sure you use Castrol, and that guarantees Castrol is going to be selling a cheap byproduct for the life of your vehicle, and you think it's the best thing for your car. But it's really not. It's all a scam. What's better about PAO and ester? Well, first of all, PAO esters, or these group 4, group 5 synthetics, do not have paraffinics, and paraffinics is a known problem in the oil industry for being the cause of sludge and buildup, which you definitely don't want in your engine. The other benefits of PAO ester are just so many. We're going to get into them later, but quickly, it has a much wider temperature operating range, meaning it can go at higher temperatures without being degraded. It has a flatter viscosity temperature curve. The friction to slide coefficient is much better with PAO and esters. This study shows that when switching from petroleum to PAO, the average savings of gas mileage was between 0.7 and 1.4%. It also can be made fully from biodegradable or renewable sources like ethanol or citric acid, which currently it's too expensive to do that, but if the entire industry would stop using dirty crude oil and start switching to full synthetics, maybe it would get a lot cheaper. Now, currently, PAO ester blends are not completely oil-free production. They do use natural gas and they require a lot of energy to create, but we are going to go ahead and get into why PAO esters have so many more benefits for you than a petroleum oil. All right, so what exactly does oil do in your engine? It has multiple tasks. Main one you already know is lubrication and removing friction. What happens is it is pumped into areas where metals would be contacting, and it provides an oil film boundary layer that prevents that contact from happening. For example, the piston and the rod and the crank. Okay, you've got a rod that's spinning on a crank, but they don't actually come into contact. If you had them coming into contact, you would have a problem. There is a hole in the crank that the oil pump supplies oil to a bearing journal in between the rod and the crank. So the rod actually floats on the crank with oil film boundary layer. This is the reason why that oil spinning test you see Project Farm and so many other people use is a bad test of oil. It's providing a spinning bearing in oil with a weighted rod pressed up against it on a point. There is no oil being pumped into that contact point. It's penetrating the oil film boundary layer, and this is a condition that doesn't happen anywhere in your engine. Now, maybe you're thinking, Micah, so if it's not a good test, why does Mobil 1 beat Redline in this test? And that's a question that bothered me for quite a bit of time, and it took a lot of research. Petroleum oils and PAOs, unfortunately, when they are being made, they are hydro-treated, and this causes them to be saturated. Think about it like lemonade when you're mixing in sugar. When the lemonade becomes saturated with sugar, no longer does the sugar dissolve into it, it just floats in there and settles at the bottom. And so friction between metals, well, that isn't actually what is handled by the oil. That's handled by an additive called anti-wear additives. In a PAO oil, it's actually not just PAO. It's a blend of ester and PAO. And the ester, as you'll see like ester core in Redline or in a lot of motor oils, is highly polar. It holds on to the additives and does not release them for the oil. Now in this test, where you have that metal to metal contact, you're actually causing a scar. That's how the test is, the results are observed. Whenever you have a metal grinding and metal being stripped away from other metal, that breaks bonds and causes a charge to be formed right there. So if you have an oil like petroleum oil that doesn't easily hold on to its additives, and then you have a charge being created, that actually pulls these additives, like the anti-wear additives, out of the oil onto the point of friction, which then lowers the friction at that point. That's why the Mobile One always tests better in this test, but this is actually proving that the oil is not as good. It doesn't hold on to its anti-wear additives. Sick of seeing that test. This is actually the reason why you have to get an oil change every year, regardless of mileage, with petroleum oils. They don't hold on to their additives, which includes more than just anti-wear, but viscosity index improvers, and we'll get into all this a little bit later. But here's a study by Falk Engineering with enclosed gear drives showing that not only can you go triple the distance with a full synthetic oil, but there's no calendar limit on how long you can use it in your car. The other thing that oil does is it is actually used as a control for systems in your car. For instance, the oil pressure is what keeps your timing chain tight. It also is what advances the cam when you want to change timing for different loads in your engine. This is one of the ways I was turned on to how important oil pressure is that when the Lamborghini SV came out, the Aventador SV, I was working at Lamborghini and we were getting check engine lights for timing advance not happening quick enough. And the result that the factory went to fix this was upping the oil weight from 5W30 to 10W60. So it's extremely important, and oil pressure is vital in both these situations, in its lubrication as well as its performing of these control functions. Maybe this is a good time to tell you you should turn that auto start stop feature off on your car. Most of the time when I see cam variator faults, it's on cars that have auto stop start features. When the car stops, all the pressure in the car slowly starts to drop and the chain becomes a little bit slack. The variator is not in the right position, and then you start it up, which normally happens once per drive cycle on a car, but with the auto stop feature, it could be happening 10, 20, maybe even 100 times on your daily drive, causing serious stresses on your engine. But hey, manufacturer says it's fine, right? So what are the characteristics of oil that are most important? Well, of course, you have heard of viscosity, right? It's those two numbers on your bottle. But what is viscosity? Well, by definition, it is the internal resistance to flow when a pressure is applied, okay? So it's basically the internal friction of an oil. The numbers that you see on your oil bottle, those are not actually the viscosity numbers. Those are just two made up numbers that refer to a scale that's set up by the Society of Automotive Engineers to classify oils. You notice there's no units of measurement on your oil bottle. If we look at the scales, there's different ways you can measure viscosity. The most common is kinematic viscosity, which has a unit of centistokes written like this. And so each weight refers to a range of centistokes. That's why earlier in the video when you saw me going which oil is thinner, an engine 30 or a gearbox 75, even though the gearbox 75 is a higher number, it's actually a different scale. This is another reason why that oil test you always see of the cold pour, which one flows better, is not actually a good test. A 40 weight viscosity is actually a range of between 12.5 centistoke and 16.3 centistoke. Mobil 1 always cheats its oil to the bottom of that range to be as close to the bottom of a 40 weight, whereas performance oils like Motul or Redline cheat to the high end of that scale. Now, why is that? Well, when you run your engine, gas gets past your piston down into the oil, and that thins out your oil. And Redline knows this, so they decide to be on the top of that range so that as you use your engine and it slowly gets diluted with gasoline, it compensates for that. This is an oil test to show you that. This is a Porsche GT3, and as you can see, it's a high fuel dilution after the end of its oil change, and that's caused the oil to be diluted down to a 30 weight. So if your engine requires a 40 and now your thin oil has been cut down by gas, you're not getting the protection your engine needs. Redline knows this, so they decide to be on the top of that range so that as you use your engine and it slowly gets diluted with gasoline, it compensates for that. But petroleum oils, why don't they do that? Remember the paraffinics? Sludge is developed with petroleum oils, so it naturally thickens. So they're expecting the gas dilution to counteract the thickening of oil as it's used over time. This is again a reason why these Project Farm tests of pouring the oils actually show that Mobil 1 is a worse oil. And they tell you, well, it flows better at cold temp. Bullshit. The difference between a Redline and Mobil is so small, this makes absolutely zero difference in how well your oil pump pumps it. Your oil pump is a positive displacement pump. It actually pumps better with thicker oil, more efficiently. So the next thing we need to talk about is viscosity and temperature, the relationship that they have, because viscosity is temperature dependent. Temperature is the average kinetic energy or moving energy of the molecules of an object. So if we look at a 1 micrometer by 1 micrometer square under a microscope of oil, we would see a certain number of molecules at room temperature. But as the temperature goes up to 100 degrees Celsius or around where your engine's operating temperature is, the energy of those molecules increase, which means that they begin to react off of each other, which means they begin to move further and further apart. So that 1 micrometer by 1 micrometer snapshot now contains fewer molecules. And if you think about what our definition of viscosity is, internal resistance or friction, if you have fewer molecules, you have less resistance or friction. This means that as temperature goes up, viscosity goes down. But Micah, my oil has two numbers, a 0W and then a 40, let's say. If you're saying oil gets thinner as it gets hotter and that second number is my hot weight, how is it thicker than the first number? So they started adding viscosity index improvers to thicken the oil. Now, what are viscosity index improvers? A viscosity index improver is a polymer or a macromolecule. It's a molecule that's made up of several things that are bonded together. So if we go back to that 1 micro by 1 micrometer snapshot, if we throw in a very large molecule that as temperature goes up, reacts off of itself and expands just like the solids do, then that means as temperature goes up, that 1 micro by 1 micrometer snapshot will be filled up with a growing, expanding molecule called a viscosity index improver. Because that you have more matter in that same snapshot, you get more friction and more resistance. Okay, Micah, so whatever, we have a way to make thicker oil. Let's just use a bunch of viscosity index improvers. Well, not so fast. There are some serious drawbacks to viscosity index improvers. One, viscosity index improvers are not oil, so you don't get the benefits of oil. You have an additive that doesn't have the lubricity and other functions that you want to get from your oil. Two, it's also extremely temperature dependent. Like anything that expands and contracts, if you overheat it, it becomes brittle and can no longer do that. That's why if you ever get an oil overheat condition or a differential or transfer case or transmission overheat condition, you need to immediately change that oil. It's not okay to continue driving on it. Here's some oil samples to show that. Here's a differential from a G63 that was locking the differential even during turning conditions, which overheated it. And it should be a 140 weight or a over 20 centistoke at operating temperature, but the test came back with it around 10. So it was burnt and was just cut down to its first oil. This also happens in engines that are turbocharged. If the turbocharger doesn't have an isolated oil supply and it shares the oil with the engine, the oil often gets burnt and cut down. Here's a Maybach that is a twin turbo V12. It was serviced at Beverly Hills Mercedes. 500 miles later, it was a 30 weight oil. The fuel dilution was still low, but it was still burnt down to less than the oil protection that it needed because of these viscosity index improvers. One of the other drawbacks to viscosity index improvers are because they are a larger molecule. Remember how we said that the piston and the crank float, but the pressure of the combustion on the piston rod actually make the area between the piston rod and the crank get thin on that side. So if you have a macro molecule, they tend to kind of line up and not want to go into that tight area, allowing more of your base stock oil in, which means the apparent viscosity in that area actually further drops. So viscosity index improvers across the board, not good. As a matter of fact, the further apart those two numbers are on your oil bottle, the more viscosity index improvers are, and it is extremely bad. Here's the owner's manual for the SLS AMG. And as you can see, it said choose the oil that most represents the lowest starting temperature you'll ever have in your car. If we look at this chart, if you're not starting your car below 20 degrees Fahrenheit, then you could go with a 2040 or a 2050. It's that important. Now they've stopped doing that because trusting you and your shops to choose the right oil is a liability for the dealership. So now they just say use a 040. Now, if we look at the relationship between temperature and viscosity on a petroleum oil, you can see that as it starts to get colder, it exponentially grows. But if we look at PAO and Ester blends, we can see that it's almost linear. As it gets cooler, it gets thicker less than petroleum oils. As a matter of fact, you can't buy a straight weight PAO. A 1040, 2050 is the closest together you can get the numbers. So PAO is a much better oil on protecting you over a wide range of temperatures. So we have an oil analysis here from a G63 that went 1,600 miles from the factory on what I assume is factory Mobil 1, and it cut down to less than a 40. So then I did an oil change with Mobil 1 040, went 4,500 miles, and it cut further down into the 30 weight range. Then we swapped in a red line, went 2,100 miles, and we're still at the top of the 40 range. No viscosity index improvers burned up with the red line PAO Ester blend. All right, so why is viscosity important to your engine? Well, according to the Hagen-Poiseuille equation, which dictates change in pressure, viscosity is directly proportionate to the change in pressure. As viscosity goes up, pressure goes up. Pressure means faster timing, it means more pressure to resist high horsepower engines, right? So why don't we just always go up with pressure? Your engine is designed to work with a specific pressure, so you need a specific viscosity. If you don't, like I said before, if you don't have the right pressure, you could have contact between metal surfaces, but if you go the opposite end and you have too much pressure, then you could have oil overheating in the bearing journals, causing it to burn and coagulate and thicken and cause negative conditions for the engine, as well as if your timing is designed to work with a certain pressure and you're suddenly putting more pressure, you'll probably get check engine lights. What is the best way to determine the best oil? And that is done by testing your oil, just like what I've been doing, taking a sample, testing it, and seeing what the results are. As far as whether or not to use petroleum or PAO Ester blends, I mean, it should be no question PAO Ester blends are the best possible oil. It's the only oil trusted by the aerospace industry. Majority of race teams use it, and it has, again, so many benefits. The only thing I'm going to warn you about is if you have an old car, you're going to have a lot of petroleum paraffinic buildup on the car that PAO ester blends are going to start cleaning out. So you may need to slowly switch over. Switch 25% of your oil to a PAO ester blend. Next oil change to 50% until you can go to 100% and not suffer, clogs or problems within the engine. Check out Redline or Motul brands. Any properly formulated PAO ester blend is going to be the best oil for your car. I'm not sponsored by Redline. I'm not sponsored by Motul. I'm just a guy who really wanted to get to the bottom of what oil is best, and it took way longer than I thought it would. Don't always do what anybody says. I don't care what kind of expert they claim to be. If it's something that's important, you should take the information that's given, test, do some research, hypothesize, try again, and test until you get it right. And oil's no exception. Do the oil analysis testing, test for yourself. If you want to share your results with me, I would love to see the data that you have. All right, guys, I hope that you guys have found this information helpful. This is the way we operate here at Hollywood Mechanic. The type of clients that we deal with are people who love their car. They want to get the absolute most power and performance out of their vehicle for the long term, and they are willing to pay a little bit extra to make sure that they never have a component failure leaving them stranded. And at Hollywood Mechanic on our YouTube channel, this is what kind of content we provide. So if that's what you want to get, you know where to find it. Anyway, Hollywood Mechanic out.